Okay, let's go talk about functions and relations. This is in the prerequisite part of it. Before you even start a review, go graph 2x plus 5y equals 20 by finding the x-intercept and y-intercept. That's something you should already be able to do, but let's go talk about it. How do you find x and y intercepts? For the x-intercept, what are you going to let be equal to 0? Let the y equal 0. If you do that, you have 2x plus 5 times 0 equals 20. So 2x plus 0 equals 20. If 2x equals 20, what's x going to equal? 10. And I think I asked you guys last week how many are still doing divide both sides by 2, so you get x equals 10. If you're still doing that step, absolutely show it. It's a good, healthy habit. Okay, an x-intercept is a coordinate. It's a point. It is an ordered pair. You have to have an x comma y. What is your x value going to be? 10. And your y value?
0.
Is 0. Now let's go after the y-intercept. To find the y-intercept, you let x equal 0. When you do that, you get 2 times 0 plus 5y equals 20. If 5y equals 20, then y equals 4. Again, intercepts are points, so you need to give an ordered pair. The ordered pair for that y-intercept is perfect, 0, 4. Okay, to graph it, on your x-axis, you need to put the point 10, 0. On the y-axis, you need to put the point 0, 4. And there's your line. Questions? Okay, determine whether a relation is a function. Some definitions. A relation in x and y is a set of ordered pairs, x comma y. We're going to talk about a relation first. The domain is the set of all x values, and the range is the set of all y values. How do you remember which one's which? X comma y is in alphabetical order. Domain, range is in alphabetical order. Domain goes with x's, range goes with y's. Questions? Okay, an example. Write the set of ordered pairs that defines the following relation. It gives it to you in a table. You need to go write the set of ordered pairs. So it's the set 3 comma negative 4. And list the other 3 points. Negative 2, 0. 5, 3, and 1, 0. Now, whether you're looking at the table of x values or you're looking at all the x's here, what's the domain of that relation? Negative 2, 1, 3, and 5. Good. It's this set of numbers, negative 2, 1, 3, and 5. Do you have to list them in chronological order? Yes. You don't have to. You could just tell me it's 3, comma, negative 2, comma, 5, comma, 1. I'd be very tickled because I would know that you knew the domain are the x's. What about the range? The range goes with the y's, which will be negative 4, 0, and 3. Do I need to list 0 twice? Nope. 0's in the list, so just leave it there. Questions? Domain goes with the x's, range goes with the y's. Okay, another definition. If you are given a relation in x and y, we say that y is a function of x if for each value of x in the domain there's exactly one value of y in the range. Another way to say that, the x's do not repeat. The x's do not repeat. To be a function, the x's do not repeat. So here comes the true-false question. Every function is a relation. Is that true or false? Every relation is a function, true or false? One's true, one's false. Okay, what does the definition of a function say? Given a relation. To be a function, it has to be a relation. So every function is a relation. Every function is a relation. But not every relation is a function. So the second one's false. So if you're given a relation, how do you know if it's a function or not? How to determine if a relation is a function? If you're given a set of ordered pairs, the rule you need to follow, the x's cannot repeat. If you see the same x value listed twice, it's not a function. Determine if the relation defines y as a function of x. How about A? I have 8, 3, 5. Did the x's repeat? No. So is this a function? Yes. This is a function. For the second one, letter B, I have -3, 9, 1, -3. Is that a function? No, not a function. And if I were taking these notes, I would go like this to remind myself. Those x's repeated, or that x value repeated. Questions? Okay, for a graph. What if you're given a graph and asked, is this graph a function? You're going to go look at the vertical line test. And the vertical line test says this. Consider a relation defined by a set of points graphed on a rectangular coordinate system. The graph defines y as a function of x if no vertical line intersects the graph in more than one point. That's the important part. No vertical line intersects the graph in more than one point.
Isn't there also a horizontal line test?
That's to determine if a function is one-to-one,
Okay.
to know whether or not it has an inverse.
Okay.
We're going to get there in the last chapter this semester. So the question was there a horizontal line test? There is, but ignore that for now. We're just going to look at the vertical line test. The vertical line test, no vertical line intersects more than once. Okay? So for A, is that graph, does it represent a function? The answer is no, because if I did this vertical line, how many times would it intersect my graph?
4,
Just twice there, right? So this is not a function. Okay, but question, what about this vertical line? How many times does it intersect?
Once.
Just once. So that passes the vertical line test, right? No. It says that no vertical line. So no matter what vertical line you draw, it can only intersect once. Well, I found one that intersected twice right here. So it does not pass the vertical line test. It's not a function. Okay, B. Would that be a function?
Yes.
Yes. If I drew that vertical line, I'd pass once. If I drew this one, I'd pass once. If I drew this one, I'd pass once. No matter what vertical line I drew, I would only pass through the graph one time. So this is a function. How about C? Is that a function?
No.
What x value is the problem child? -2 right here. If I draw a vertical line, I pass it here and there. So this is not a function.
If one of those points was an open circle, it would still pass though, right?
Okay, so the question is, if I change the problem, so let's go over here and do D. And my function now looks like, say, this. I just gave you the answer. My graph looks like this. Is that a function?
Yes.
Yes. This one is a function. Because if I drew this vertical line, I would only pass through it one time. That's a hole, right?
Yes.
So that would pass the vertical line test. That is a function. Teaching this class more than one time a week. I don't remember which class I tell and which class I don't. When you play the what if game, it totally changes the rules. So it's a whole nother problem, right? This problem is completely different than that problem. And you see that because one's a function and one's not. So just be careful. When you're in the tutoring lab and you start playing the what if game, just recognize it. You're changing the problem. All right, so we've talked about how to tell if a function is if a relation is a function, if we're given a set of ordered pairs, the x's can't repeat. If we're given a graph, it has to pass the vertical line test. And now let's go look at it. What if it's a mapping? Mapping meaning you're making a relationship from a domain to a range. Could you give me the list of ordered pairs from this mapping? What would the ordered pairs look like? This is kind of an aside. You'd have 1, 2, you'd have 3, 2, and you'd have 5, 4. Do the x's repeat? So is this first one, is that a function?
Yes.
Yes, this is a function. The second one, what are your ordered pairs? 2, 4, 3, 4, and 8, 4. Do the x's repeat? Is this a function? Yes, that's a function. Do we care if the y's repeat? We don't care. So the rule, again, the x's cannot repeat. If you have a mapping that looks like this, so this x value is going to go over here to 2 different y values. This is not a function. Does that make sense? So if your arrows go like this, it's not going to be a function. Function notation. What if you're given an equation? The rule says you must explicitly be able to solve for y. Must be able to solve for y explicitly. Meaning y equals something. Okay, you need to get a y to the first power equals something as well. So determine if the relation defines y as a function of x. That first one, y squared equals x. Is that a y equals something? No, this is not a function. Look, bad. If you tried to get y by itself, you would get plus or minus the square root of x, correct? How many equations do you see there? 2. That is not a function. The second one, x squared plus y squared equals 25. What do you see? A y squared. That's actually a circle centered at 0, 0 of radius 5. This is not a function. If you knew it was a circle of radius 5, would that pass a vertical line test? Mm-mm. This one over here is a parabola that opens which way? Sideways to the right. Would that pass a vertical line test? No. The third one, y equals absolute value of x plus 3. If I were to tell you that that graph looks like this, would that pass a vertical line test? Yes, that is a function. Can you solve for y equals on that one? Yep.